some exceptional cases. So let's think of this problem. Solve the following assignment problem. It's a very simple statement that they have given us. Solve the following assignment model or problem. Right. So they have given us a 5 by 5 matrix.
Second, discuss about the similar problem. Third, any polynomial differential we are facing. Yes, please. As a subject teacher, I call it
right. So this is the question that they have given us. Solve the following assignment model, and now we are going to apply our the algorithm what we have seen. So what is the first what is the first thing that we have to do? We have to go for row reduction and the column reduction. So using a Hungarian model, Hungarian method, the first thing that we have to do is row reduction. All right. So I'll be performing the row reduction. 2, 3, 4, and 5. 1, 2, 3, 4, and 5. Right. So row reduction. So in first row we have the minimum value as 8. Right. So we have to subtract 8 from all the other values. So 11 minus 8 is 3. 17 minus 8 will be 9. 8 minus 8 is 0. 16 minus 8 is 8. 20 minus 8 is 12. Nextly, we have in the next row we have 6 as a minimum value. So 9 minus 6 is 3. 7 minus 6 is 1. 12 minus 6 is 6. 6 minus 6 is 0. 15 minus 6 is 9. Right. In the next cell, in the next row, we have a minimum value of 12. Right. So 13 minus 12 is 1. 16 minus 12 is 4. 15 minus 12 is 3. 12 minus 12 is 0. 16 minus 12 is again 4. In the row number 4, the minimum value that we have is 17. So we are going to reduce 17 from every of these cells. So 21 minus 17 comes out to be 4. 24 minus 17 comes out to be 7. 17 minus 17 comes out to be 0. 28 minus 17 comes out to be 11, and 28 minus 26 comes out 26 minus 17 comes out to be 9. Lastly, row number 5, we have the minimum value as 10. So 14 minus 10 is 4, 10 minus 10 is 0, 12 minus 10 is 2, 11 minus 10 is 1, and 13 minus 10 is 3. So this is how we have performed the row reduction. We are moving ahead and we are going to do now column reduction. Right. So column reduction. So what we have achieved in row reduction is that in every row we have achieved at least 1 0 by using the row reduction. Right. Similarly, in column reduction, what we are going to achieve is that we are going to get at least 1 0 in every column.
So number is not a problem. Number is not correct.
Right. So for column reduction, the row reduction matrix, that is this particular matrix will has at input. Right. So in first row we have 1 as the in first column we have 1 as the smallest value. So reducing 1 from each of the cell in that column. So here it will be 2 2 0 3 3. Right. Similarly, in second column now we have 0 as the minimum value. So all that column will remain as it is. In third column also 0 is the minimum value. So all this column will remain as it is. In fourth column again 0 is the minimum value. So all this column will remain unchanged. In the last column, if you see, the minimum value is 3. and that is to be reduced. So 12 minus 3 comes out to be 9, 9 minus 3 comes out to be 6, 4 minus 3 comes out to be 1, 9 minus 3 comes out to be 6, and 3 minus 3 comes out to be 0, right? Now we have going to perform the row and column scanning. So perform row and column scanning, right? So for the row scanning, we have to check whether we will be starting firstly with the row scanning. We are going to check whether there is only 1 0 in row 1, and if we are going to proceed likewise. So if we have this in row 1, we have only 1 0 here. We are going to put one square around this 0, and then we are going to draw a vertical line. Very importantly, a vertical line is to be drawn, right? Nextly, okay, I'll be repeating this step on the next page, so that you will be understanding it in better fashion, and it will be easy for me to explain as well. So just a minute. We'll be copying this value, so column reduction. Okay, 29089. It is 21606. 21606. It was 04301. And next was 370116. Next it is 30210. 30210, right? So this was this what we have: 1 2 3 4 5, 1 2 3 4 and 5, right? So let's do row scanning and the column scanning. So firstly we have one single 0, and we are going to draw a vertical line. Moving towards next row, we have again one single 0, and we are going to draw a square and then a vertical line. Moving towards the third row, we again have a single 0. We are going to put a square, and then we are going to draw a vertical line. Row number 4, we do not have a 0 here, so we can't put allocation. And row number 5, again we have 2 zeros, so we can't do any we can't put any square around this 0. Let's do the column now we have finished with the row scanning. After row scanning, we'll have to ask the questions if all the zeros are cancelled. No, all zeros are not cancelled. So we are going to move towards the column scanning now. In column scanning, first column is already cancelled. Second column, yes, we have only 1 0. So we are going to put a square here, and now here we are going to draw a horizontal line. Let's move towards column 3. It is already cancelled. Column 4 is already cancelled, and in column 5 we do not have any 0, right? So now we're moving towards the next step. What we are going to do is, here the number of squares is equal to how much? Number of squares is 1 2 3 4. Number of squares is 4. Number of rows or columns, number of rows or columns is equal to 5. So 4 is less than 5, or no, these values are not matching, hence the optimal solution is not reached, and we'll have to iterate further. Hence iterate further. Hence we are going to iterate further, right? So now when we are going to iterate further, what is the what is to be done? We have to identify the minimum value, which is from the undeleted cell. So if you see, the minimum value from the undeleted cell that we have is 1, right? So minimum value is 1, right? Reconstructing matrix, and then perform row and column scanning, right? So no, what we have to do is that when we reconstruct this matrix, we are going to add the minimum value at the intersection lines, and then we are going to reduce it from the what we can say, from the undeleted cells, and all the other cells value remain constant. So if you check where the lines are intersecting, the lines are intersecting at row 5, first cell, then it is second, third cell, and the fourth cell. So 3 plus 1 will be here 4, right? Here it will remain same. I'm just writing for the intersection cells. So 2 plus 1 will be 3 here, and 1 plus 1 will be 2 here, right? Now for the undeleted cells, so undeleted cells, 9 minus 1 is 8, 1 minus 1 is 0, 4 minus 1 is 3, and 7 minus 1 is 6. Other undeleted cell, if you refer to, 9 minus 1 is 8, 6 minus 1 is 7, 6 minus 1 is 5, 1 minus 1 is 0, and 6 minus 1 is 5, right? And all these cells will remain what? All these cells will remain same. So here it will be, here it will be 2, 2, 0, 3, right? Nextly, here it will be 0 only, here it will be 0 only, and other, what we can write as 0, 8, 6, 0, 3, 0, 0, and 11. All right. So this is the thing that we have got. Now what we are going to do next is that we are going to perform the row scanning and the column scanning. So for the row scanning and column scanning, the same thing we will have to repeat. We'll have to ask whether the first row consists of a single zero, and if yes, we are going to put a matrix. We are going to put a square around it, and then we can move ahead. So here we have only one zero, so we have put zero. We have put a square around it, and then we are going to draw a vertical line. Nextly, if you see, we have 2 zeros in row 2, we have 2 zeros in row 3, we do not have any zero here in row 4, and 2 zeros in row number 5, right? So just name this. Now what we'll have to do is we'll have to go for the column scanning, right? So when we go for this column scanning, in column number 1, we have this as this cell as the this 0 here, and we are going to put a square, and then we are going to draw a horizontal line. Very important is the horizontal line that we need to draw, right? Moving towards column number 2, we have 2 zeros. We cannot address this column, so we'll be skipping this column. In the next column number 3 is already been cancelled. Column number 4, we have only 1 0, so we are going to put here we are going to put a square here, and again we are going to draw a horizontal line. Lastly, in column number 5, we have only 1 0 1 0 here, and then we can we can put here a square, and what we are going to do here is we are going to draw a horizontal line. Now you can check, we have cancelled all the zeros here, and now let's calculate the number of squares. So number of squares are 1, 2, 3, 4, right? Number of squares is equal to 4, and number of columns is equal to 5. So have we got the optimal solution? Iterate further, right? So how we are going to iterate further? We are again going to identify the least cell here. So the minimum value here. So the minimum value here is minimum value that we have is equal to how much it is? 2, right? Yeah, it is 2, right? So the minimum value 2 is here 2. So So reconstructing, no, we will have to reconstruct and then perform row and no column scanning. Right. So let's reconstruct this matrix again here. So we have a very sorry because the pen ink has finished and I'm imagining these lines and no drawing. So just bear with me for this lecture. Right. So what we have is for 2. Right. So here it will be here it will be 0. Right. So 8 minus 2 will be 6 here. Right. So here it will be 0. Here it will be 6 and here it will be 6. Similarly, we have this entire, this is like 2 0 2 0. Then we have 6 plus 2 is 8 here, 0 and again 5 here. Right. So 0 for the third row we have 0. So what we'll have to do is it is already cancelled. So here it is 0, then it is 3, then it is 5, and then it is 0, and then it is here it is 0. Right. Then we have undeleted cells. So 3 minus 2 is 3 minus 2 is 1. 6 minus 2 is 4. Right. So 0 minus yeah, 0, here it will be 0 only. 11 minus 2 is 9 and 5 minus 2 is 7. Right. Lastly, we have this cell, that is 4 minus it is cancelled. Right. So it is 4 0. Right. So 3 plus 2 is 5, 2 here, and lastly it will be 0. Right. So now what we are going to do is here is we are going to perform the row and column scanning, and let's see in which we have identified that the minimum value was 2. We were going to reconstruct the matrix and we were going to perform the row and column scanning. So after the reconstruction of the matrix gave us this matrix. Right. So there were 5 rows, 1 2 3 4 5 and 5 columns. Right. So the reconstructed matrix that we got was 0 6 0 6 6. It was 2 0 8 0 5. It was 0 3 5 0 0 and 1 4 0 9 3, and it was 4 0 5 2 0. Right. So now here what we have to do is we have to perform the row scanning. So the same procedure, we are going to check whether the respective row contains only 1 0 or only 1 0 or not, and if not, then we are going to skip that row, and if yes, so we are going to make a square around that 0 and draw a vertical line. So let's start with the row scanning. The first row consists of 2 zeros, so it is not possible here. Second row consists of 2 zeros, again it is not possible here. Row number 3 consists of 3 zeros, again not possible. Row number 4 consists of 1 zero. So right. So what we are going to do is we are going to draw a square, and after that we are going to draw a vertical line passing through that 0. Right. Again, for row number 5 we have 2 zeros, and we cannot do row scanning here. So now after row scanning, there are many zeros left. So we'll have to definitely perform the column scanning. So let's start with the column scanning. So first column consists of 2 zeros. So again, not possible. Second column consists of 2 zeros. Not possible. Third column is already cancelled. Fourth column consists of 2 zeros, not possible. And fifth column consists of 2 zeros. And again, here column scanning is not possible. Even if we repeat, after column scanning, we'll have to check whether all zeros are cancelled. So no, many zeros are remaining. So again, after column scanning, what we'll have to do is we'll have to again go for row scanning. So after row scanning, let's do row scanning again. So row number 1 consists of 1 0 only. So let's mark a square around this, and now we are doing again row scanning only. We'll have to draw a vertical line. In the similar fashion, we'll be proceeding in second row. We have 2 zeros, so not possible. In third row, we have 2 zeros, not possible. And in fifth, we have again 2 zeros, not possible. Let's do column scanning. Column number 1 is already cancelled. Column number 2 consists of 2 zeros, not possible. 3 consists of 3 is already cancelled. 4 consists of 2 zeros, not possible. And 5th consists of 2 zeros. Again, it is not possible. So again, column scanning also. Again, after column scanning, we'll have to check whether again row scanning is possible or not. So now again, checking the row scanning. You can see that in row number 2, row number 3, row number 2 and 3, we already have 2 zeros, so not possible. Fourth row is already at rest, and fifth we again have 2 zeros, so again not possible. So now after repeated cycles of column and row scanning, also these zero will remain. These zeros are not going to get cancelled. So now how to move in this particular fashion, right? So these problems are of unique type, right? So now we'll have to decide something. So now what we'll have to do is that after repeated these things also, here we cannot iterate also, right? So for iteration, we require all the zeros to cancel, right? So we again cannot go for iteration. So what we'll have to do is that we'll have to do some different step. That is, now we are into a unique situation. So this unique situation again needs a unique way of handling, right? So what is this unique way of handling? So we are going to arbitrarily select zeros. Now in row number 2, what we are going to do is let's check. We are going to select this particular 0. So when we select this particular 0, so this is a column. We are going to cancel all the zeros in that row as well as in all the zeros in that column as well. So we are going to cancel all the zeros in that row, and we are going to cancel all the zeros in that column as well. So row and column, all the zeros are going to get cancelled for that particular arbitrary mistake, right? So again, in third, we have a choice to select here again. So here again, we are going to select this first 0 only, and what we are going to do is we are going to cancel all the zeros in that particular in that particular column, as well as all the zeros in that particular row. Lastly, we have only 1 0 left here, so it is possible here. Again, we are going to make a square here. So now let's check out our optimality condition. Number of squares is equal to here is 5, and number of columns or rows is also equal to 5. So hence what we have got is the optimal solution. Hence optimal solution reached. So what may happen in this particular numerical is that there are multiple optimal solutions, right? So there can be an instance that I have selected this particular 0. It may so happen that you select this particular 0. So it doesn't matter. But basically, what we are going to do is that we are going to select first 0 in that particular row, and the next 0 we are going to cancel. So what we did here, this was the first 0 in that particular row, hence we have selected this. This was also the first 0 in that particular row, hence we have selected. So it's a normal convention that everyone globally it is followed. So you also followed the same thing. So now if we this particular finishes our problem.